video, we're going to look at adding and subtracting rational expressions. There are a few things that we want to remember when adding and subtracting rational expressions. The first, we're only going to factor the denominators. Unlike with our previous examples where we were simplifying, multiplying, or dividing rational expressions, at the end of this problem, we're going to be combining our numerators, so we want to make sure that they're not in factored form. We're going to continue to state restrictions, just like we've seen in all of our other examples. And then the last, probably most important component of adding and subtracting rational expressions is your LCD, which is the least common denominator. That represents the expression that all of your denominators will divide evenly into. 1 over x plus 5 plus 6x over x minus 5. In both of our denominators, we don't need to factor anything, so we skip straight to our restrictions. Looking at our denominators, our restrictions are -5 from the first denominator and +5 from our second denominator. Our LCD is going to be an expression which both x plus 5 and x minus 5 will divide evenly into. Now, a very easy way of constructing a common denominator is to multiply your different denominators. So in this case, we will use x plus 5 times x minus 5. Now that we have identified our LCD, we're going to go back to our original problem and we're going to modify each individual fraction so that it has that common denominator. Looking at my first fraction, I already have x plus 5 in the denominator, so I need an x minus 5 to complete the LCD. Since this is an expression, I can't just change the denominator. I have to change that expression by what we call, or what I call, the special one. That's anything divided by itself. If you take any expression and divide it by itself, that simplifies to 1. In this case, we're going to use x minus 5 over x minus 5. Again, multiplying by this special one isn't going to change the value of that term, but it is going to change the way it looks. And the way it looks is important in being able to combine those two fractions. In our second fraction, we already have x minus 5, so we need x plus 5. And we will multiply by x plus 5 over x plus 5. So simplifying my two terms, I've got now x minus 5 divided by x plus 5, x minus 5, plus 6x times x plus 5 divided by x plus 5, x minus 5. We have two fractions now that have the same denominator, so we can combine them, and all we're going to do is add our numerators and keep it over that LCD. X minus 5 plus 6x times x plus 5, all divided by x plus 5, x minus 5. We need to simplify our final answer, so we're going to distribute the 6x and work on combining like terms. X minus 5 plus 6x squared plus 30x over x plus 5, x minus 5. And that simplifies to 6x squared plus 31x minus 5 over x plus 5, x minus 5. So now we've effectively added these two fractions, but when we look at this numerator, 6x squared minus 31x minus 5, or excuse me, plus 31x minus 5, it looks like it might factor. If we kind of do some brainstorming, we would factor this using our AC method. We need factors of -30 that sum to +31. So are there two numbers that we can multiply to get -30 that add up to 31? My first thought is 30 and 1. But because I need a negative product, one has to be positive, one has to be negative, which is not going to give me a 31 sum. 15 and 2 is another factor of 30, 6 and 5. None of those combinations are going to work. So I have tested that this will not factor any further, which means I know it's not going to simplify any further. And this is my final answer, along with our 2 restrictions we had from the very beginning. Let's take a look at another one. 2m minus 20 over m minus 6 minus 8 over 6 minus m. In this example, again, starting with the very first thing of factoring the denominators, we have m minus 6 and 6 minus m. Now, individually, they don't look like they should be factored, but noticing the similarity between those 2 expressions, m minus 6 and 6 minus m, hopefully you remember from maybe a previous video or other examples that we want to change the order of this second denominator so that the variable comes first. 2m minus 20 over m minus 6 minus 8 over negative m plus 6. And now that we've changed the order, we have a negative lead coefficient in that second denominator. We always want to factor out that negative lead coefficient. If I factor out the negative 1, I'm left with m minus 6. And that's what we were trying to get. We recognized the pair of denominators that we had, and we knew that we could rewrite them so they looked the same as long as we factored out that negative. Now this negative 1, since it's a factor of the denominator, can actually float. We can put it in the front, or we could put it in the numerator. So it doesn't really make any difference, but I'm going to move it to the numerator. 2m minus 20 over m minus 6 minus negative 8 over m minus 6. Everything has been factored. Let's state restrictions. Since our denominators are the same, our restriction is the same for both. M cannot equal 6. And because we have the same denominator, we can go ahead and combine our numerators. 2m minus 20 minus negative 8 over m minus 6. Combining like terms, the negative 20 minus negative 8, when I subtract a negative, that's the same as addition. So this is the same as negative 20 plus 8. 2m minus 12 over m minus 6. And in this example, again, we see that the numerator might factor. And if we do factor it, factoring out our GCF of 2, we have m minus 6 over m minus 6. And we can simplify this. The m minus 6 factors cancel out. This entire expression simplifies to 2. We still have our original restriction of m cannot equal 6, but that entire sum, or excuse me, difference, is 2. 2x over x squared minus 9 minus 3 divided by x squared minus 4x plus 3. This is a clear example of where we need to factor our denominators. 2x over x squared minus 9 is a difference of 2 squares. It factors to x plus 3, x minus 3, minus 3 over x squared minus 4x plus 3. Because my lead coefficient is 1, I can jump straight to my 2 binomials leading with x. And then I'm looking for factors of 3, positive 3, that sum to negative 4. So it's going to be negative 3 and negative 1. Now that our denominators are factored, we state our restrictions. X cannot equal negative 3, positive 3. Here's another positive 3. We don't need to restate it. And also positive 1. And now we will figure out what our LCD is. Our LCD, again, is an expression that every denominator needs to divide evenly into, or it's the product of our different factors. So our LCD is going to have a factor of x plus 3, x minus 3, and because I'm running out of room, I'm stacking this vertically, but they're all being multiplied. From our second denominator, I need a factor of x minus 3, which I already have, and I need a factor of x minus 1. So our LCD is the product x plus 3 times x minus 3 times x minus 1. We go back to our original problem and we figure out what do I need to multiply each denominator by to get our LCD. In the first fraction, we need an x minus 1. So I'm going to multiply the entire first fraction by x minus 1 over x minus 1. In our second fraction, we need the factor of x plus 3. So I multiply the entire fraction by x plus 3 divided by x plus 3. 2x, just a second, 2x times x minus 1 over our LCD, x plus 3, x minus 3, x minus 1, minus 3 times x plus 3, divided by our LCD, x plus 3, x minus 3, x minus 1. Now that both of our fractions have the same denominator, we can combine the numerators. I'm going to go ahead and distribute the 2x, and I'm going to distribute the 3. So we have 2x squared minus 2x minus, and I'm going to use parentheses because I'm subtracting that entire second numerator, 3x plus 9 over x plus 3, x minus 3, x minus 1. Now I need to distribute the negative. Two x squared minus 2x minus 3x minus 9 divided by x plus 3, x minus 3, x minus 1. And we combine like terms. 2x squared minus 5x minus 9 divided by x plus 3, x minus 3, x minus 1. We recognize our numerator as a quadratic, a trinomial quadratic. So let's look and see whether or not we think we can factor this. Factors of 2 times negative 9 is negative 18. That's sum to negative 5. So let's think about that. Our factors of negative 18, 2 and 9, not going to give me 5. 6 and 3, not going to give me 5. Any other factors? I don't think so. So this is not going to factor, and this is our final answer. Along with the 3 restrictions that we stated at the beginning. It's really important that we carry those restrictions through the problem with us. Just like we've seen when we were simplifying, multiplying, dividing, none of the restrictions go away just because the expression changes. 6 over x minus 5 plus x minus 35 over x squared minus 5x minus 2 over x. We're going to start by factoring our denominators. 6 over x minus 5 won't change. X squared minus 5x has a GCF of x, so we will factor out x. And that's times x minus 5 minus 2 over x. Our restrictions, x cannot equal positive 5 from the first denominator. In the second denominator, we have 2 factors, so we have to think about both of them. The first one is x, so we have a restriction of 0. And then we have positive 5 again, which we don't need to restate. And then in our third fraction, if x equals 0, that's undefined, we already have that restriction stated. Now we want to figure out what our LCD is. Since our first denominator has a factor of x minus 5, our LCD will have a factor of x minus 5. In our second denominator, we have a factor of x minus 5, which we already have in our LCD, but we also have a factor of x. So we need a factor of x in our LCD as well. Since our last denominator only has a factor of x and that's already present in our LCD, we're good to go. In our first fraction, we need an additional factor of x. So we will multiply the entire fraction by x over x. Our second fraction already has our LCD, so we don't need to change it at all. And our last fraction needs a factor of x minus 5. So we will multiply the entire fraction by x minus 5 over x minus 5. So we end up with 6x over x times x minus 5 plus x minus 35 over x times x minus 5 minus 2 times x minus 5 over x times x minus 5. Since we all have, or all of our fractions have the same denominator, now we can combine our numerators. And in the last example, I went ahead and distributed. I'm going to show you the other option where you don't have to distribute. It might work a little bit better for you guys so you don't forget that negative. If I go ahead and combine as is, I've got 6x plus x minus 35 minus 2 times x minus 5. And this is all being divided by x times x minus 5. You can see now in our next step, we're not going to distribute 2, but we're actually going to distribute the negative 2, which might help some of you so you don't forget that sign. 6x plus x minus 35 minus 2x plus 10 divided by x times x minus 5. We combine like terms. We have 6x, 7x minus 2x is 5x. Negative 35 plus 10 is negative 25. Divided by x times x minus 5. And in our numerator, again, we can factor out that GCF of 5, so let's try it. 5 times x minus 5 divided by x times x minus 5. And it's a good thing that we factored the numerator because we see now we can cancel out our x minus 5s. This entire expression simplifies to 5 over x. With our original restrictions of 5 and 0. So again, things to remember when you are adding or subtracting rational expressions. You only care about factoring the denominators in the beginning. You might factor the numerators at the end, at the very, very end when you're trying to simplify, but in the very beginning, just factor the denominators. When you factor the denominators, that will help you state your restrictions, which you'll need to do, and it will also help you identify what your LCD is. We'll see you guys next time. Thank you.